Saxon Math 42.B for the advanced math course is circles, and we're going to be first of all describing what a circle is and how it works. We've had the definition before of a circle in a little more of an elementary type method, but this method that we're going to be describing a circle is the locus of points that are all equidistant from a given point. Now, we're going to call that given point the center of the circle. Now, let's go back to the word locus. Locus, a lot of times people confuse that with a line because they're very similar in that a line could be a locus of points as well, but it's a collection. A locus is a collection. And so as we're going to say, it's the collection or the locus of all the points that are the same distance from a given point. And I drew a circle over here, and I think this is pretty standard for a lot of people. This is pretty basic. But I look at it and I say, there's my center of my circle. And I look and I say, the locus or the collection of all the points that are the same distance all the way around from this one point. And we're going to do that on a plane. And that's important that we understand that a little bit later. We're going to define a sphere as the locus of all the points that are equidistant from a point in three-dimensional space. But for right now, we're just saying this is the locus of all the points on a plane. Now, let's talk about how that works on a circle or a Cartesian plane. And we're talking here about or discovering how we would take and come up with an equation that would describe a circle. Now, up to this point, we understand that if I had, for instance, y equals x squared, we understand that that is going to graph as a parabola. And so I understand that a linear function is going to be a straight line, and when I put that squared on it, I end up getting a function, and this is a refresher. So y equals x squared would give me a function that is going to go up in a parabolic shape. And I remember that y equals x is a straight line. That's not going to help me graph a circle. And I remember that y equals x cubed, well, that's got a tail going down and up like this, and still isn't helping me get to a circle. But if somehow I could capture this and come up with it going the other way, well, that's fine. So x equals y squared, that graphs like this. Well, if we could somehow place the two of those together, and they're both going to have squared terms. X and y have to be squared for this to work for a circle. Now, with that in mind, and just as a quick unit circle that I have here, I have my unit circle, and I said, well, if I know x and I know y, then I know r. Well, the reason I know r is because of the Pythagorean theorem, which a squared plus b squared equals c squared. Well, how would I apply that to here? If I look at this, I realize that this is my x term, here's my y term, remember, because this is my y-axis, here's my x-axis, and I have my r. So if I could relate this and say x squared plus y squared equals r squared. Well, how would I get this to move? This is going to be centered at the origin here, and that's going to define this circle. This is a very, very basic definition of a circle right there. Because it's going to tell me whatever that is, whatever x and y are, as they vary and change, it will describe as x gets positive or negative, or as y gets larger or smaller, fixed by my r value, that relationship between those will graph out a circle. However, how would I get something to move left or right? If you remember on our previous lessons, to shift or to translate a graph left or right, I would add it inside the parentheses to the x value. So in other words, if I put x minus 2, it would translate it to the left, or to the right 2. If I did x plus 2, it was to the left 2. Well, if I did that and I say, well, that's my left and right translation, how do I do an up and down translation? Very similarly. And I have the standard form of a circle written out here for us. X minus h squared plus y minus k squared equals r squared. Now, once again, there's my r, and that's my radius. Here's my left and right movement. Now, a lot of people get confused because you have to remember x minus this number. That means if my equation ends up as x plus 2 squared, that's really hidden in there is x minus negative 2. Because that's how I have a positive 2 in there. So my formula is going to be this. A lot of people like to memorize this formula. It's not a bad idea. X minus h squared y minus k squared equals r squared. This is my left and right steering wheel. This is my up and down steering wheel, if you want to think of it that way. And this is my radius. So this is how big the circle is going to get. This is how far up and down that circle will shift. This is for how left and right the circle shift. Now, what if I wanted to write this in a more standard form? For instance, this is not something that I normally can use in this format. Other than the graphing, I would want to have a general form of writing this. So this is a standard form. Well, the general form is I take the standard form, there it is, and I go ahead and square x minus h. When I do so, I say x times x is x squared, x times h is a negative xh, negative h times x is a negative hx, and negative and a negative h is a positive h squared. When I do the same thing with the y's, and I'll leave this up here on the board for you, but I won't take the time to multiply this all out, I end up with this right here on the y's, and then I move the r squared over by subtracting r squared from both sides. When I do so, I start collecting my like terms, and the general method, the accepted method of writing this is going to be the x squared term goes first, alphabetical order. The y squared term goes next, because those are the highest ordered pairs, or highest ordered terms. And then I go to the next terms that are, there I have a 2hx and a 2ky minus my r squared. This is going to be my general form of writing a circle. Look at your books, if you will, and this is example 42.2, and this says, find the equation of a circle whose radius is 4 and is centered at -3, 3. Write the answer in general form. Now, the book, I did shorten our answer, or our question just a little bit, because they did ask for it in both standard and general form. When I do so, I'm going to start with, first of all, my standard form. Well, I write my formula out. This is why it's important to memorize this formula, because this will help me throughout my work. The next thing I did is I went ahead and sketched what it would look like. So I said, well, if it's centered at -3, 3, well, back 3, 1, 2, 3, and up 3, 1, 2, 3, and that gave me the centered point. Remember our very first thing we talked about? The definition of a circle is the locus of points equidistant from a given point. So here it is, that point equidistant is 4. So I come out 4 and I draw my circle. Now I don't have a perfect circle here, I realize that, but this is just a sketch. I don't have to have this perfect. This gives me a good idea of what it's doing. I then look at my origin, I say, well, where did it go? Well, it went back 3. So I put in a -3 for h. X minus a -3. This is the confusion part for a lot of people. Pay very, very close attention. My formula had a negative in it, and I moved back 3. Therefore, my formula is going to have a negative, my problem had a negative, and I end up with a positive here. I do the same thing with k, except that k went up 3, so that was pretty easy. And that made it y minus 3. And now I have my standard form almost done, except that I realize I'm going to slip in my little 4 in here for the r, for my radius, and I end up with a standard form of equation. So there we go. I took it from my word problem to my sketch, to my standard form of the equation itself. This is very, very useful form because I can graph from it immediately. I look at this, and this describes the mathematical relationship that this problem took a lot of words to do. Remember, that's all algebra is shortcut writing long English words. So there we go, we have it written down. Now, once it's in standard form, I convert it to general form the same way I did over here. I think it's easier when it's real numbers because I have a lot of terms that I collect. So I go ahead and do that. X plus 3 squared is x squared plus 6x plus 9. Don't forget to FOIL. I can't just say x squared plus 3 squared because I do have two terms multiplied by two terms. I have to do my FOIL method or left to right method to expand that. The next one, y minus 3 squared. That's going to give me y squared minus 6y plus 9. 4 squared, that's a tough one here, 16. At this point, I start to collect my like terms and put it in the correct order. If you remember, the correct order is going to be my x squared term first, my y squared term next, and that's why I just collected those. So x squared was already there, y squared I moved to the front after that. The next step in this is go ahead and collect the x terms. Well, there's only one 6x, and I put it here. And the y term, negative 6y. I move the 16 over to the left hand side and I collect the 9 and the 9. So 9 plus 9 is 18, minus my 16 gives me 2. And now I have the equation of my circle in general form. There are other ways to write circles in other forms that we'll learn later, but for right now, all they're asking for you to know is the standard and the general form of writing a circle. And now that you can see how to go from that direction with this, we could certainly sketch the other direction. The reason why this is so important, once again, is this is a little bit more difficult to do by hand if you were given general form, which we'll get to. But if you have a standard form or a word problem, sketching the correct circle that corresponds to it is extremely easy, and you can see it right here.